Thank you for your patience, ladies and gentlemen. This is a masterclass. It's Sensestack, Impact to Causation, Observability, Stack built on OpenTelemetry. We have our speaker, ladies and gentlemen. Please welcome him with a big round of applause. Mr. Shiva RV, Deputy Chief AI Platforms, Build National Payments Corporation of India.
Hi, good morning, everyone. Am I audible? I'll quickly introduce myself. Sorry? No, not at all. I'm good. Actually, you can get these tables. All right, sorry for the delay in starting. It's been a little, I think, the traffic is catching up. So I'll quickly introduce myself. Joined NPCI in 2020 as an architect on the platforms, and eventually took up the responsibility of designing the new age platform back then, as in like the new data centers. As we all know, in 2021, we cut over to our own greenfield data centers. So my team and me, we all together worked on this journey. And post that, it has not been an easy ride. But one thing what we realized is we needed a unified observability platform, an end-to-end platform which can actually do the entire skim, or say it should skim the entire platform and tell us what's happening where, because it's a large platform, you know the scale. Right? All right, so the first challenge that we faced was the silo challenge. How many of you work in an organization where you need to coordinate between 100 plus engineers at a given point of time? Excellent. All right. So let's try to understand the kind of teams that we always see. We have business operations team. They are the ones who understand what's happening on the business side. Then we have the application and the software development team. These are the engineers who write the code, who compile the code, so on and so forth. They know the business. They are the ones who are implementing the business functionality into software code, into tech. Then comes the infrastructure team. They are the ones who are actually building the bare bones on which the software stack is running. And then we have the cloud and orchestration teams. These are the ones who are bringing the software, hardware, all of it together and making them talk to each other to bring out the output. Right? So 4 different teams. Fundamentally, what we have realized lately is that when there is a situation, as in like when there is an incident, let us say, an unfavorable time that we are going through, the silos, because none of them or all of them have their own unique languages. Right? The business teams will talk about their business metric, and the software team will talk about their software language, and so on and so forth. The bare metals people will talk only about the bare metals, and the network team will talk about the network. And the cloud team will say, hey, you know what, I'm trying to understand what's happening on the business side. I don't have a clue. Right? So it's a siloed challenge. Everyone is working in silos. Now let's add a little more chaos to it. Alerts. We all have gone through it. Alerts are fundamentally something where we said, okay, this is a condition. If that condition is met, you notify. That notification used to be emails at one given point of time. Now they have advanced so much that the team's ringtone has become a meme. At least for me, for sure. It rings, it's like a horror story. So think of a lot of false positive alarms also coming in. There are many times where, these static thresholds won't work. It has to be a lot more intelligent, and noisy alerts are a known issue in the industry. Right? When you add the noisy alerts or false positive alerts into the siloed challenge, trust me, it's chaos. It's definitely chaos. Next slide, please. So, before we straight away jump into the solution or how we chose to solve it, let's try to understand what are the caveats or what are the prerequisites. Because at NPCI, next slide. Let us try to understand NPCI's not only compliance but the entire complex construct If we happen to choose, if we happen to see NPCI, it has to be 100% sovereign infrastructure because it is the digital financial backbone running UPI, IMPS, AEPS, RuPay, NFS, CTS, NACH, so on and so forth. 100% on-prem greenfield data centers, which means we are not doing it on a public cloud where we can take infrastructure for granted. We have to give that guarantee to our ecosystem. So we don't operate on a public cloud. We are the ones who are heavy lifting it. I have my colleague here who does it every day. So he eats dust every day for his breakfast, I guess. I don't know, strong people. They're the ones who run the show, right? Then PCI DSS compliances, security compliances, regulatory requirements, what we have to adhere to, right? Because end of the day, we are not doing business, we are enabling businesses. We are ensuring that businesses run. We are ensuring that money is moving from one point to another. So it's not about, the impact is not one, it's multifold. Then the scale of the systems, we all know it's population scale systems. Unfortunately, India is the largest populated country, but yes, a boon and a bane too. We are the largest market too. So think of the scale. It's just UPI alone has processed 19.63 billion transactions September. Only UPI alone. Well, we did not still include the rest of the applications or services that we run. So it's large. It's, I think, largest is what I can say in the world in terms of volume of transactions, not the value, but volume of transactions, the number of transactions, UPI alone. It has surpassed some of the largest networks, payment networks in the world. Then let's try to trickle it down to the IT infrastructure. Now, because we are sovereign and we are national critical infrastructure also, we cannot have a single vendor risk. Again, risk and compliance kicks in. So take a look at the number of OEMs for each and every category, right? Either it is an open source software where we cannot be arm twisted by a single vendor, but when it comes to the hardware, we have ensured that we have choices. Like for example, we have bare metal servers coming in from 4 different OEMs and we are exploring more. I hope to see a lot more Make in India initiatives also happening. I am very sure in the next couple of years, we will have Make in India servers also coming in, apart from the global brands that we are already seeing. On the networking side, this is a very unique struct for us. We have all the network operating systems, or say all the network fabrics that are present out there. You talk about the classic 10 gig copper network or a 1 gig copper switch to a 100 gig, I think we have even upgraded to a TIG switch now. We have the TH5s from the Tomahawk 5s. And we have Cisco, Arista, Mellanox, NVIDIA, Mellanox. Before NVIDIA's acquisition, after NVIDIA acquisition, we have the NVIDIA silicon. Then we have the white boxes, EdgeCore, UFI space. On that, we have Sonic, we have Arcus. So we have our network constructors it's like a shop by itself. It's like a supermarket of network. So we have, and we learned our lesson through when there was the silicon crunch was happening. We all know the phase, the COVID and the xenon gas availability crunch in the globe. So we learned our lesson. Networking is something that can actually make a standstill for our growth. So we ensured, we redesigned, we went back to the whiteboard. We literally brought in anything and everything that we could get from the market at that enterprise grade. Then on the firewalls, we have at least 2 OEMs and can't reveal the names of course. And then we are on the SD-WANs, we have 2 different OEMs coming in. Then storage racks, we have 3 different storage racks. These are at petabyte scales. And then, by the way, in the storage racks, we are also using Ceph and Manio as well, which are the open source. So apart from the NetApp, the HPs and the Hitachis, we have Ceph and we have Manios running on JBODs and JBOFs. So it's a complicated storage architecture as well. Now on the open source components, we have Kafka for message streaming, Cassandra for NoSQL database. We are using KeyDB for in-memory database. All our applications are written on Java, Spring Boot framework. And we have orchestrations using Kubernetes as well as OpenStack. Kubernetes on both OpenStack as well as on bare metal directly as well. So the complexity that comes in is large. And this is what we do. We are a little model heads is what we call, and we chose to solve it for UPI scale. And UPI does it all, which is the world's largest payment ecosystem in terms of volume. And let's try to understand the scale. 19.63 billion transactions alone in September 2025, latest metric, which trickles down to 431 billion API calls monthly. And if we have to talk a per second average, it is 1,66,000, approximate some 281, if I'm not wrong, average requests per second is the scale that we're looking at. On top of it, add the encryption layer. We have TLS, of course, end-to-end TLS across external as well as internal. Then, if we convert that down to telemetry signals, we have our telemetry scale can be directly compared to what the Ubers or the Netflix are doing today. We have, at peak, we easily touch 1 million spans per second. A quick explanation of what is a span. Span is just an event. Like I am talking, you're listening. Every word is reaching your ear. Every word reaching to your ear is a span, is an event. So recording each and every event, at peak, we have seen million spans per second as well, at scale. And it is a highly heterogeneous platform, as you can see, which means the signals that we collect, metrics, logs, traces, and then on the log side, we have the hotel logs, and we have the application logs as well coming in. Some are structured, some are unstructured, so we have to parse them on the fly. Some at the source, some in the middleware, so on and so forth. And last but not the least, 4 sites, all are active. You don't know which UPI transaction is going into which site. We can track that back, but just think of an end user, you don't know which site it is going to. Your transactions are getting processed in any one of these sites. All are active at a given point of time. The next slide, please. Yes, please. Guys, there are seats. Please walk in and spread yourselves. Yes. Yes. You can come here in the front as well. All right, so what's the solution? Now, we did it in silos, like how the classic industry does. It's not like we did not try. We tried different tools, different methods, different approaches. We failed. I shamelessly admit we failed. But the good part is, for every failure, there is a learning. We get into war rooms. We might fight. We might argue. We might debate. But at the end of the day, the best part is the outcome is always a successful outcome. So we did identify a solution how to go ahead. And that's what the whole masterclass is about. How are we trying to solve, or what is the approach that we have taken? And yes, as of today, we are definitely seeing very good results there. So quickly moving forward, the philosophy is impact to causation. Let's try to understand or break these down. Impact, victim, the one which is impacted. Cause, the accused, the one who caused it. So fundamentally, if we look at the observability ecosystem, a key factor that is missing, which we identified, or at least for us, which was missing, was the cause could be technical, could not or need not be technical, but the impact is definitely on the business side. Or in other words, there might be many scenarios where there are technical failures, but if there is no business impact, it is generally considered to be a simple tech debt than to be an outage situation. Why? There is no revenue loss. There is no negative impact to the ecosystem. So unless there is an impact, the causation layer is not seen very keenly, right? So our thought process was, let's create a correlation between the impact layer and the causation layer and see how can we remediate and find the root cause analysis as quick as possible, because the faster we are able to identify the infection in the system or the fracture in the system, the faster we can heal and the better we can perform and give more reliable service, right? So quickly moving forward here. So as you saw the previous columns, now they have been merged. And the impact is on the top side. and the cause is on the bottom layer. So whenever there is a business impact, most probably there is definitely a technical impact, unless there are certain foreseen situations like, climatic conditions, like rainy seasons. We definitely see the network which is connecting or interconnecting the banks to NPCI to, kind of have that hiccups. But otherwise, in most of the cases, the impact when it is seen on the business layer, the causation layer has to be identified, and we have to definitely identify whether it is under the purview of NPCI or not. And if it is, then definitely we have to do something better than what we have done in the past. We have a learning on the table, right? So the fundamental idea was bridging impact to causation. And that's how we call it as a unified telemetry platform or a unified observability platform. Don't just be siloed with your technical signals alone. Correlate it with your business metrics. That's our fundamental learning from this entire exercise. And the whole idea was how fast we can do it. It's not just about to do it, but how fast can we do it. Next slide, please. Next slide, please. Yeah, next one. So let's quickly take a look at how traditional observability systems are designed. It's a classic ETL pipeline. Extract the signals in terms of metrics, logs, traces. They're collected from sources. Let it be the servers, let it be managed services. If you're on a public cloud, you have CloudWatch in AWS, so on and so forth, respective things. But end of the day, you're extracting, then you transform. You might want to make them more like, you might want to create an average of it. Percentile, that's a transform. And then you export as unlike load. ETL, classic ETL pipeline, right? Load. You then export it. The catch here is that the industry today is actually doing the entire pipeline and then performing the root cause analysis and then performing the anomaly detection after it is loaded into storage. Just for everybody's understanding, storage is the slowest component in the entire IT ecosystem in terms of data loading or extracting. Memory is the fastest, okay? So in other words, think of you knowing a formula in your mind versus referring to a formula written in a book. Writing a formula in a book and then referring to it you need to know in which page number have you written that, then go to that page, read that formula, load that into your brain and then speak it out or apply it with your pen. That's as good as like a hard disk or storage. But if you remember the formula in your mind, if you're good with math or if you're practiced enough, you can actually do an in-memory calculation. Just in the air, you can do the calculation, right? Same analogy. Fundamentally, don't load and then compute the anomalies. Rather, do it before. Shift left. That was our learning. Next slide, please. Next slide, please. So this is the approach that we took. If you observe carefully, we are still collecting them, but in a transformation layer, what we have chosen to do is to detect or to perform near real-time anomaly detection. So OpenTelemetry, I'll give a quick background, around 1.5 to 2 years back, all the telemetry standards were fused together. They were brought into a common standard called as OpenTelemetry. The project was led by Linux Foundation and CNCF, as in Cloud Native Computing Foundation. If a particular project or a software is listed or say it is incubated into CNCF, consider that there is zero vendor lock-in. As in like, now the foundation owns it. No one can shut it down. It's vendor neutral. And the best part about OpenTelemetry is it is not a solution, it is a specification. Like UPI is a protocol, OpenTelemetry is a protocol. They defined a specification saying like a metric should look like this, a log should look like this, a trace, which is a more detailed verbose event description in technical format, has to look like this. This is the fundamental construct. And they created the language. And we have to adhere to the sovereignty and vendor neutrality and zero vendor risk and so on and so forth in terms of compliances. So we chose OpenTelemetry, which was an obvious choice. Open source, open standard, vendor neutral, not owned by a given entity. It is owned by a foundation which is working in the progress in terms of technology. So obvious OpenTelemetry, but we just did not stop there. Whatever enhancements we did, or whatever we kept on creating as software code, we started contributing them to OpenTelemetry ecosystem itself. Now we chose to do it into the OpenTelemetry ecosystem because not only us, but adopting to open source puts another responsibility on us to contribute back to the ecosystem as well, right? So the first contribution that we did was on the real-time anomaly detection on streaming telemetry. Just think of it, as your online transactions are happening, there are continuous events. All those telemetry signals are being passed into a pipeline, and that pipeline is actually learning, and then it is creating the anomaly score, one. Second, same philosophy applied for alerts as well, right? So the alerts generator, again, an in-memory processing, you perform your rules, but don't fire. I'll come to that slide a little later to reduce the noise, how we have done that. But fundamentally, our idea was analyze, and then again, don't store everything. Store only that is anomalous, because our intent to have this was not to perform business analytics. Our intent to perform this was to know what went wrong where. As in other words, we don't want the good stories, we want definitely the bad stories to be there for a longer term. So don't store anything and everything, rather store what is needed. So that way we can even reduce the storage costs. Because for a scale of UPI, if we are talking about storing it for like even 5 days or 10 days, it will hit a petabyte scale straight away. Because we saw the telemetry signals, right? Sometimes we even hit 1 million spans per second, so large, it's really large. So quickly moving forward, the next slide please. So this is the first isolation forest. So we first chose isolation forest. Reason is very simple. It does not need an external machine learning service or an ML. It is a well-known, well-established algorithm. So what we did is, we took the online isolation forest. A quick difference between regular isolation forest and online isolation forest. Isolation forest algorithm runs on static data. It batches the data, like you can say 0 to 5, then 6 to 10, then 11 to 15, so on and so forth. You're batching the data and you're performing the anomaly detection. Online is a moving time window. It is no more a static window, it's a moving time window. The good part is now I have a contributor from the ecosystem. He is proposing a variable time window as well. So that PR is under review, I'm looking at it. I'm looking at the code change. So fundamentally the first contribution was, let us do it as an online system, learn it for a specific period of time, short period of time, enough for a volume like UPI, but of course that can be fine-tuned. As you can see, there are so many parameters that we have introduced. You can configure forest size, subsample size, contamination rate, threshold, mode, training window, update frequency, minimum sample, so on and so forth. So we hear to these data scientists, they sound like rocket engineers to me. Being a platform engineer, they sound like rocket scientists. They say, I have to tune the model. I have to tune the model. I have to make it learn. I have to teach it. So it has always sounded like a rocket science to me, but after looking at it, all I realized is in simple abstract layer, they have to perform testing on the same data with multiple combinations of these parameters and find the one which is most accurate. In simple words, I have used my grandpa's radio, tuning the frequency, to tune the radio to the right frequency and to get the least static to listen to my favorite song. I have to put some effort. Tuning or model training or anything is as simple as it. I mean, I'm definitely trying to make it sound very easy. It is not that easy, but yes, end of the day, you're just playing with a combination of these numbers. Thanks to AI, you just ask what is that particular parameter mean. It will give you a quick abstract English-based definition, and then you can start playing. Now, because this is being orchestrated on Kubernetes, what we did is, we started streaming this telemetry into 10 different pipelines with 10 different combinations of the same parameters, and then we started seeing the anomaly scores. And definitely our business teams, we are running the show, so we clearly know what is really anomaly, what is not an anomaly. So with that, we were able to tune these parameters. So for UPI kind of a scale, every week we keep checking the accuracy. We have our own ways of communicating with each other across the teams. So my team, what it typically does is, out of this 10 variations, which variation did detect the anomaly the fastest in the least amount of time. They look at it, they look at the human signals, they look at the telemetry signals, and then they say, Shiva, this particular combination is doing better. So in simple words, evaluation in parallel. So we're not just doing it one by one by one. So no more batching because it's streaming data, we are really running fast. Kubernetes is allowing us to deploy the same model 10 times with 10 different combinations, and we're able to evaluate really, really quick. Again, as you can see, features is nothing but, features in the language of data science or data engineering is nothing but number of unique data points or that needs to be analyzed. That is features. And then performance, yes, of course we have to take care of the infrastructure. We cannot have infinite infrastructure. So yes, memory tuning. So we clearly know at what throughput of UPI in terms of transactions will require how much memory, CPU, and how many workers, like the computing cycles per anomaly detection. So that way we were able to do a pprof and we fine-tuned it. It's already released in 0.132 of the OpenTelemetry contrib pipeline. So pick it up, feel free, and you can play around. The next slide. This is with the alerts gen. This is right now the PR review is going on. I've done a lot of mistakes in the code. I'm yet to correct it. I've asked my engineers also to take a look at it. So we're running faster. But what we have done is we have also deployed it parallelly for local dev testing, and we are seeing it to be effective. Those are more sanity errors or mistakes that we have done. We are fixing it. We have found the sponsor. We couldn't get the sponsor for almost like 4 or 5 weeks because alerts is a very sensitive topic. The moment we proposed it as a feature request or feature addition in the community, we could see a lot of engineers jumped in and they had a lot of inputs. So I had to attend a couple of SIG meetings, special interest group meetings, and then convince them, tune that feature request, and then finally bring it out. Maybe a week to 2 weeks down the line, even this feature will be out. Best part is, now you can actually generate alerts in real time, so you need not load it into your, or you need not write the data in your notebook and then read it and then say, there's a good answer, bad answer. Before saying the answer, you can decide whether it is a good answer, bad answer, and only tell the good answer in memory processing. So you're faster now, right? Put the QR code so you can just go, maybe if you have an input, feel free, add a comment in GitHub. It's on the OpenTelemetry. So the issue is open still, so feel free. Even on the isolation forest, I've put the QR code, scan it. You can add a feature, or if you wish to contribute, most welcome, the more the merrier it is. Now, the architecture. As I've already explained, what we have done is, we have done the ETL, and then we thought, how do we do the root cause analysis now? Obviously, we don't need real-time root cause analysis, because when an incident occurs, our priority is not to identify the issue. Our priority is to ensure that business continuity is in place. The root cause analysis follows later, which is a repercussion that we have to go through, obviously, but to ensure that we don't repeat our mistake, which means we have time. And memory, again, being the fastest is also the costliest. So here we chose, we will load and then we'll perform the root cause analysis. Because RCA is something that needs calm minds. When we are in the battle zone, we cannot sit and discuss state politics. In simple words, right? Think of a soldier in the battlefield. So obviously RCA gives you time and we need calm minds. Let the incident be over. Let us ensure that the business continuity is in place, the disruption is as minimal as possible. Then let's get into a room, perform a root cause analysis, hence we are loading it. And then what we have done is we have created a couple of microservices architecture. And our choices were very clear. Again, open source, shift left, and ensure Apache 2.0 license, right? And we have a vector database. There's a specific use case for vector database. One of the asks when our team was interacting with business teams as well as the SRE teams was, Shiva, how do we know what do you mean by a slow query in Cassandra? And there's a question coming in from my business ops team. And at the same time, a core SRE is coming and asking me, saying like, Shiva, how do I know what is a UPI error code? I don't have the knowledge. I have to literally run behind. And then I have to probably refer to the document that I have. It's not easy for everyone to go through. And there are shifts, there are new engineers coming in. How do we ensure that everyone has one common knowledge? So we chose, I mean, we can solve it by a traditional database or a document store, but no, we thought it's the era of AI. Everyone is speaking English and writing code. Why not think one step ahead and create this in a way that probably in future we might want to launch a small bot with which my business team or SRE team or even the security guard, of course, yeah, that's a joke, sorry. But even anyone, a fresher who's joining us, will be easily able to understand the system, talk to it in simple English, and it will tell you what's happening. So think ahead, think of creating something which can complement that journey. Hence, we chose a vector database with graph query language or GraphQL. So all these definitions, we are now storing it into the vector database. We are vectorizing it. Where there is GPU availability, we are vectorizing it using the GPU or a large language model. Or if not, what we have done is in our software code, we have created a hash-based vectorization also. So if there is crunch of GPUs, you create hashes. In simple words, a vector database is a semantic search. I'll say apples are costly, but oranges are cheap. Now you see there is a dual thing. Yeah, we all know Apple devices are also costly, and Apple as a fruit is also costly. So now you have a confusion between which apple is it being referred. But the moment you bring in oranges into equation, you have a more reason or a bigger reason to say, okay, this is a statement about apple as a fruit, right? But the moment I say apples are costly to fix, but oranges are cheaper to afford. The moment you see a fix word coming in, now you know, okay, no one fixes an apple. Anything which is human made can be fixed. If nature breaks it or a natural element breaks, it's broken, right? So obviously that gives in a little more context and says, okay, the first statement is about Apple as an IT device or handheld devices or MacBooks or whatever. But the second one is definitely a fruit, right? So how is this differentiation coming in? That is because of vector search. In other words, GraphQL's similarity and the nearest way in terms of context. So this is how AI engine is working. It is able to understand our dialects. It is able to understand our slangs. Every generation brings in a new slang. How is it knowing all that? That's because of this. So there is a vectorized database which is precisely helping these models to understand the context and connect and give the nearest answer. You might have seen AI models hallucinating or imagining something or giving you a wrong answer. The root cause there is the vectorization is not giving them a very powerful way of connecting the dots to understand the context. So that is where we say, okay, you need to give a better prompt. The better prompt is nothing but give a more contextual statement so the AI model can actually create the context, understand, yes, connect the dots properly, so that the intent is properly understood, right? So it's all done by the vectorization and the vector database, how well it is indexed, and how intelligent is the model in terms of fetching this data and understanding and creating context around it. So that's exactly vector database. So we also chose a vector database. We are right now testing VV8. It's an open source Apache 2.0 software available with source code. So we are testing its scale, not yet production grade, but yes. And then of course in memory for paginations and other stuff. And what we are typically doing is we are not only storing that, but we are also classifying. So in the entire AI ecosystem, we have to train these models, right? So what we are doing is we are taking the business data and then we are classifying, okay, success rate. We first create a definition. What is a success rate in this particular UPI as an application? And is it an impact layer metric or is it a cause layer metric? We are classifying that also. Then the third one we are saying, what is the sentiment? Negative sentiment, positive sentiment, how is it being decided? End of the day, it's all numbers. So we are saying decrease of success rate is negative sentiment. Three things we are tagging. And what we have done is for all the components, we have already found out the top 10 most important metrics, logs, traces, log fields, so on and so forth. We are creating these definitions and we are loading them into the vector database, right? Now, quickly what typically happens is, go to the next slide. Let us say there is an incident happening or we see a negative sentiment kicking in. Let's try to understand how the system works. First, we are trying to plot all the signals on the same timelines. In other words, chronology of events. Right? So you can see the x-axis is timeline, the y-axis is the measure of the signal. Right? And then when a negative sentiment, think of it, we have acceptable thresholds, x and y. And we say UPI success rate cannot go below y%. That's an agreed SLA with the ecosystem for us. But definitely we are doing above y for sure. The more the merrier, we are happy. But doesn't mean that when it starts falling, we don't wait for the y to be hit. The y is hit, someone's at the door knocking. So what we are typically doing is, we are continuously measuring the success rate, and the moment we see a negative sentiment happening in terms of the trend of success rate, we are quickly invoking our RCA. We're not waiting for it to fall till the Y and below that. We are kicking in before that itself. And this is how we are doing it. T is the timeline, or say timestamp at which we identified that there's a negative trend. Okay? But the threshold has not yet breached. So we are still in a good phase. I say that as the orange phase. We need to act. Or a yellow phase, a warning phase. We create quick anomaly rings. T minus 5 as an anomaly ring, T minus 10, T minus 30, T minus 60, and T minus the timestamp. When was the last change done in the production? From our change management control. We get that timestamp as well. So these are the anomaly rings. These are configurable in our system. And then we are invoking a 5i rule, RCA. And how are we invoking that? We know business metric. Wow, now we have plotted all the top 10 most important signals of each and every component. We are throwing all of them onto a single graph. And simply strafe from right to left. And see what are our anomalies in each of these anomaly rings. And we are saying, okay, if we are considering the issue could be in the last 5 seconds, or the invocation of this issue has happened in the last 5 seconds, mostly the first component which has shown an anomalous signal there is the area of infection. We are not saying that is the root cause, but it could be the last step before the root cause. Okay? So if we go manually look at it, and then if we keep feeding that data into the system over a period of time, this will become a lot more intelligent over a period of time. Next slide, please. Yeah, so this is the entire flow. In simple words, think of it. Hey Mira is the bot I named. I said, hey Mira, how's UPI doing in the last 15 minutes? Just think of our CEO asking this to this chatbot. How does it actually work? All it does is, it sends that request to the Mirador core. Mirador stands for watchtower. There's a small component that we named. All the core does is, it collects the UPI transaction metrics and logs without any PII, of course. There's a lot of sensitivity that already happens. There's a lot of cleansing that we do. And then parallelly, it goes and collects all the metrics, logs, and traces from the technical systems. Then it will also perform something called as the service connectors. In other words, which component is dependent on which one? Who is the client, who is the server? Right? So it also gets that equation, the entire schematics of the architecture. And then not only that, it also fetches the definitions of these metrics, because we have already preloaded them. And then it creates a nice prompt. Now we have to be sovereign. We cannot send our data out. So what we chose is, we chose the open source models like Llama, Mistral. Fundamentally, what we're doing is, we are creating this prompt. As I've said previously, your answer from the model will be as intelligent as your prompt is. So we are giving, or we are also creating a UI where, our engineers, our SRE teams, our business teams can also modify the prompt for it to do better. Right? So the prompt is configurable. So right now I just put in saying like, hey Mira, you're a Spring Boot expert, you're a Cassandra expert, you're a KDB expert, so on and so forth. So that way I'm creating the jail, or say the boundaries in which it needs to operate. And I'm saying, okay, I'm going to feed you the hotel traces. And I'm also giving you the business metrics, where this particular metric is an impact metric. This one is a cause metric. Impact and cause are pretty English, so it already has those dictionary meanings in it, being a large language model. And then we are passing that to the model subsequently for the model to process and give us a non-technical English readable answer, which all these models today are able to do that. So this is how we are actually stitching this entire story. So this could be an invocation done by anyone in the ecosystem having the right privileges, or as I've said previously, the moment there is a negative sentiment detected, because everything is built on REST APIs, all you need to feed in is an incident ID, a start time, and an end time. That's it. And it will start doing the RCA. And whatever it identifies, it is feeding that back as a document into the vector database again. Why? Let us say if there is really a technical issue that has been identified, we need to learn from it. In future, we need to refer to it. So we are storing it in the vector database again. So maybe 6 months down the line, if we see a similar trend, now it knows, okay, last time there was this, there is a concept called as regenerative learning. So our SRE teams post the RCA analysis can go manually verify and say, yes, this RCA is right. It chooses to be stored in vector database. And now next time when some kind of a technical run happens, all it will do is it will also include the previous RCAs. And it will refer that also to give you a better RCA this time. And with new models coming in and new learnings happening, yes, we are very confident that this will move forward in the right direction. Next slide, please. So these are some of our open source contributions. You can skip this next one. Yeah. So I'm up for questions. Quick time check. Are we done? Or do you have time for questions? We have time for questions? Okay. Time for, yes, please. Hey, hi.
How do you measure the negative sentiment? You said that there is a feedback loop. How does that come at?
In which phase?
Say there is an error on the user side.
Okay.
How does that flow back to you in some way?
See, if we're talking UPI, we don't get that. So if you understand UPI, right, let me explain the internals a bit. When you do a transaction on, let us say, Amazon or Flipkart or Swiggy or anything, right, that transaction is hitting a payment gateway or an aggregator. That is hitting a bank. That bank is then coming to us. So fundamentally for UPI kind of a system, we don't know how exactly the end user's journey is looking like. But if we take the classic journey of Beam, let us say, I have a couple of engineers already here in the audience. In Beam, we are doing one step ahead. We are also collecting a bit of telemetry signals from the mobile app as well. So the concept is the same. The approach is the same. When the telemetry comes in, all we need to do is we have to define it. What does that signal mean? Then second, say increase of it is negative or increase of it is positive sentiment or decrease of it is negative sentiment. Define that. We know these metrics. We know these signals, right? And then you also define this is an impact layer or cause layer. 3 things. So this classification and collection of telemetry signals from all the sources which are playing a role as far as possible. Yeah, I can't ask the ISP router to also give me signals. Not possible. But yes, I can measure the first mile, I can measure the last mile. The middle mile, something that we can probably calculate. Yes, please.
I have a product question on observability.
Please.
So how do you make sure that different systems, the platform services within your ecosystem are all mapped to a single outcome, right? So you say like a transaction successful, right? But some system might be calling it differently, transaction TRX, send success, XYZ. How do you define a common language that actually...
Perfect. So we don't define a common language. What we do is, we let the application developers choose their language. Let those signals come in. In the onboarding process, we are creating the definitions, right? Again, someone is calling it as TXN underscore success. Someone is calling it as just success. Someone says some XYZ. Someone just says transaction state or final state. Doesn't matter. The point is, in the onboarding stage, we know what are all the metrics that we are getting, what are all the log fields we are getting. We are choosing the top 10 fields. Again, as said before, 3 things. Define what does this metric mean. Classify if it is impact layer or cause layer. Third, clearly define increase of this particular metric is good or bad sentiment. That's a one-time process, right? So unless UPI application team chooses to change that field name entirely, which does not happen every fortnight for sure, then we are in a bigger trouble. But this is a one-time activity. We have to go through it. It's called labeling and cleansing of data. Yes, please. Sorry, that answered your question? All right, excellent. Yeah, please.
All right. Do you expect the signals that you receive are to be in a standardized form or the Sensestack take case of normalization of that? That's number one. And number two is, if you could just give an insight of how this solution has helped NPCI being proactive to get a bad news over the reactive.
Perfect. So, answer to your first question, if we are using the standard OTel libraries, as in like the logs, metrics, traces, they are standardized. Because OpenTelemetry is defining the specification. It is already defining what it should look like. What should it look like? What is a trace looking like? What is a span looking like? What is the duration? What is the time stamp? It is epoch in nanoseconds. It's already clearly defining the telemetry standards. The only challenge is where we are collecting the application logs and transaction logs. One-time activity again. It's not an easy task. Even yesterday we have been discussing about one of the thing where we clearly say, look, if you're changing the format, let's predefine those format. Don't at least change the labels. Maybe you might want to change the struct. So it's not often that it happens regularly, but it's a one-time exercise again. There are multiple solutions, right? Multiple solutions to do that. In simple words, we can do a PCRE and then convert the PCRE regex patterns, and then we can convert them into JSONs. Fundamentally, we are expecting them to come in JSONs. If it is metrics, we are saying it's a key value pair because it has to be stored into a TSDB. By the way, there is another feature that we want to push into the OpenTelemetry. There is already one which says span metrics. It converts all the spans into metrics. That's already there. The second one is recently I'm seeing signal to metrics. So you can actually feed any log into it. It will extract and it will convert them into Prometheus style or TSDB style metrics. So the day that happens, I am also trying to, I'm also saying, hey, I want to be there with that developer. The developer is quite into, he's not still responding. But yes, the idea is with that, the entire drama of, converting that non-standard data into standard data will be gone.
Last question, please.
Yes, please. Shiva. Great stack you built, observability. So are you doing it for the security observability also?
Sorry?
Security observability. You're definitely doing for performance and availability. Since you're taking all the events.
Go back further. The moment I change this intent, right? Go forward. Next. And the moment I change the prompt, now you have an SIEM solution.
Thanks.
It's all about collecting and processing. Does that answer?
So you can change person ID you just feed whom you're serving, you can change anytime.
So I'll give a quick story about this. My dad took me to engineering counseling. I had to choose a seat. I was confused. Then my dad said, Shiva, look, you have multiple choices here. Make a choice which looks like a boiled potato. Can be consumed as is, can be cut and put into salads, or fried and eat it, or do whatever you want to do with it. A boiled potato is multi-purpose. So the whole idea is that, I don't know, it got embedded in me so much that I started thinking abstract. So when we fundamentally designed the system, our thought process was, it could be a platform. Just think of, okay, I have some affinity towards automobiles. If you know the Honda engines in India, all engines, you take the Brio, Honda City, the CRV as well, all of them have one single engine, but they're tuned to different states to give different outputs. Same is the case with the Suzuki engines. All the Maruti petrols or the Fiat diesels are the ones which you see in the Maruti Suzukis. They're all one single engine. They're being tuned for different states to serve different purposes, right? Yes.
Shiva, when you start to make the pipe learn, right, at real time, what sort of lag are you actually experiencing?
Good question. So this is where the way we constructed, we have 4 sites, right? So what we are doing is, we are actually ensuring that there is one Sensestack standing in each and every site, but the source is actually shipping it to all 4 sites of Sense. So fundamentally, the priority is very geographical. So let us say at site A, if I'm there is the latency in the site A application to site A sense is going to be the least because it's just 3 hops away in the data center. But obviously, when that signals are going to the other data center, I have to add the latency of site to site with SD-WAN and seasonality and all that. So our idea is that when we start producing the signal of a stack where the Sensestack identity is also being sent, notified. So we clearly know if site A sense is talking about site A UPI, that is the fastest signal. Obviously, plus the site-to-site latency is when we will receive the alert from the other sites. So it's very geographical. So it's tunable again. We can choose, okay, for which stack, which size. So at the source itself, we are shipping it to multiple destinations. Asynchronous it is.
Yeah, one last question.
Yes.
Can we ever achieve true understanding of the causation effect of distributed systems, or it is always probabilistic in nature?
There is no ideal engine in this world. Answer is no. Accuracy can never be 100%. We tend to become 100%. It will always go to 99.9999, count your nines, but there is no ideal engine. There is no 100% efficient engine. This is coming from the laws of physics. This is no different. Because end of the day, all this computation is happening on physics, thermals, cycles, and math. You might want to bend physics and bend maths, but we cannot change it.
Well, thank you so much. Any other questions? I think we're good.
Please. Yeah. Perfect. I see 3 questions coming in. First one is labeling. Is it really that black and white? Answer is yes. I'll tell you why. My CPU load can increase, but it cannot be the business, the ones which is bringing me revenue. CPU load is a metric that is not generating revenue. In simple words, think of the top 10 metrics which are directly indicating the revenue being generated. Success percentage of UPI, revenue. It is an impact, not it is a cause. See, cool. Okay, I see what theory of relativity. Where you're standing, right? The intent, our position is at the top of the stack where we are talking revenue as our impact. Okay? Now, if you are a performance engineer, you're not talking revenue. For sure, you're not talking revenue. You're talking about CPU. So then your impact layer is CPU. Change your labeling. I'm talking with respect to revenue generation. You're talking with respect to performance. So for you, the impact is CPU. So it depends on what hat you're wearing. For a day, for a change, I took CEO's role when designing this system. Does that answer your question for the first one? So that's on the labeling part. Your second question was on, sorry, I lost. Yeah, so which depends on what? The answer is very simple. That is a very nicely created equation. I'll tell you why. When you take a look at OpenTelemetry, right, you clearly know when a span is seen, who's generating the span, who's sending the request, that becomes the client, who's receiving it becomes a server. So you clearly know who's dependent on whom, right, for that particular event. So for every event, you have a giver, you have a taker. So that is clearly defining the dependency matrix. In other words, there is the service connector or something is there. Signal connector, service. Sorry, slipped my mind, my apologies for that. But in OpenTelemetry, there is a connector which precisely looks at this telemetry and clearly tells you 3 signals. 1, the dependency, who's the client, who's the server. Second, RED, rate of requests, errors, and duration. All 3 it generates, RED metrics, right? So there is a processor there, there's a connector there which clearly indicates this. In our RCA, we consider that. We clearly know who's dependent on whom. Because when we throw it, again, if you want to do it, you can do an indirect measure as well. When you throw all these metrics into a timeline, right? The one which is generally the dependent, or say the one which is provider is the one which will crap out, and then later you will see the error on the client side. Okay, the degradation is always seen on the one who is server, and then the client is getting impacted. So the degradation, I'm not talking about the impact, right? What was the third question? Cool. Okay.
Well, thank you so much because we're just running out of time for the next speaker to come in. Yeah. So.
All right. So I've left my LinkedIn QR code as well. So feel free if you have questions, post me there, pull me into, drag me into conversations. More than happy to interact, collaborate, and do it bigger, better. If you can contribute, please help us. We are also contributing. So the more the merrier. Let's do it bigger. Right? Thank you, folks.